I gotta get Jordan's stuff ready. Oh, it's
No, I knew I was doing some homework and then come back.
Go get water. I don't think she finished. She didn't finish.
I need a new notebook and no papers. I just want
Yeah, I'm gonna do this after because I started doing my period responsibility.
Right. Jordan, it was calculator active the whole time, so I'm gonna set you in the back because I'm just gonna be tutored a lot.
Jordan, I really like your haircut. Like, please.
Oh, you did get a haircut. I knew something looked different. How much you can cut off? That one looks different.
Yeah.
Looks nice. It's not this short. It's really hard. Don't do it. Don't ever do this.
Why?
And then like no shorter. Like a 10.
Okay.
Okay, shoot.
Ready?
Yeah. Yeah.
Okay. So pretty much you can, you know, when you're minusing x's and plusing x's on the iceboxes, it can be pretty hard math, okay? So we try to simplify math as much as we can by trying to use the x, but if the math's going to be like square root, cube root, or something more complex, and you're like, let's try to neglect x and make our math simpler. And the only reason, I shut the door because Jordan's taking a test back there.
Well, okay, can Brittany take a test in here or you tutoring?
I'm tutoring,
Okay, well, I mean, it has nothing to do with
but I'm going to be loud and obnoxious.
That big.
Okay,
tutoring too, but I
that's why I shut your door.
I know, I'm just on my way back through.
Okay,
I'm sitting right there, I know.
I was just telling you.
I'm smart.
Anyway, the purpose of simplifying the math is to help you with your problem. Solve for x. You still want to solve for x. So you're not going to neglect all the x's because you still have an x to solve for. But the only conditions that must be present is you must have a very small theta. And that's basically saying if you have some reactant and you're subtracting x and adding it to the product side,
I see what you did.
and add very, very, very little products because your K value is like totally telling you the reactants are favored. The reactants are favored, very little products will be made. Good so far?
Yeah, they probably say though, like, you didn't use any of the extras.
I did. And that one complex one I did?
But
I left one. Oh no. I'm sorry.
it was like one squared over.
Right. So that what happened was I had amounts present initially for each of the three.
For multiple choice.
Yeah. So I had like 1, 2, and 1 or something like that. And then I subtracted x, added x, and added x.
Yeah.
So essentially, I was following the rules. I only neglect the x's that are added or subtracted. So it's like 1 minus x, neglect 1 plus x, neglect 2 minus x. So I followed the rules, but then the math didn't work out. I got a number. Right.
Oh, that?
We're gonna see a couple of
So
them.
you can use Y.
But the way that you verify that you're okay to neglect x is that x is negligible when the value of x is 5% or less of the smallest number.
Like the smallest like coefficient.
No, the number the quantity of a reactant product you would have added or subtracted from.
Like with 2 minus x, so like
Yeah,
1 minus x.
yeah, whatever that concentration
So
is,
it's
not
like
coefficient.
the initial.
Yeah. All right, so I did. This is neglecting x. I'm gonna do probably 2 from here. This is on your. Yes, you were.
Oh, yeah.
On kinetics. Tara, kinetics. Thermo. Kinetics. I said everything. I said because some people's multiple choice.
right? Is everything?
That is kinetics. Yes.
Yes. But the last one we weren't.
Thank you. Okay. Some people did, and I just
Wait,
for
we
each
were
one.
supposed to do what? What were we supposed to do?
It doesn't matter. I'm trying to get this done.
Grandma, are we just supposed to put the right answer or the wrong answer?
Explain. Explain. Yeah. Okay, so if you're given the initial okay, first of all, you're given the Kc value be 10 to the negative 13. That's like kind of blaring in your face, like, nope, this is going to be probably really hard math, so let's try to neglect x. If the initial concentrations of that, and that are that, what is the equilibrium concentration of iodate? So you have your BCE first step. If you want to write this example down. Rice table.
Oh, right, the BC down. Up it right. Okay.
And then write your initial for iodate. I'm sorry. Water. Water was liquid water, so that's irrelevant.
Okay. The third mechanism.
Okay. And I don't know if I'll go through and solve. I should solve all the way. I'll try this. So that's your icebox. You notice you have 0 of those products, so you have to add that side, right? So you have to proceed that way. So you're going to minus 7x's here, minus 7x's here, add 1x, and add 5x.
The sum reaction
Has the same overall sodium.
Okay, so then you get 0.0020 minus 7x, 0.065 minus 7x, x is 5x.
What is your picture? Sorry, it's like a picture.
What is the KC expression?
The concentration of I2. Oh, wait, you with the X's in it?
Oh, well, yeah, we'll go straight here.
So X, oh wait, yeah, X times 5X.
X to the first
Or
term.
times 5X would be to the 5th. And then over 0.065 minus 7X to the 7th. And then 0.002 minus 7X.
Crazy math. 7th power.
Just cross the X's out on the bottom.
Only the ones that are added or subtracted.
And then so you have
Oh, this equals
1.0 and then negative.
Right. So you take your equilibrium value times, this, whatever the product of blah blah to 7th, blah 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 to 7th is.
So let me
I can calculate.
What the heck? So, wait, what am I doing?
Cross multiplying.
I had 2 seconds, so I wrote down for a second.
Oh, you're just crossing off the X. So your
Yeah, I'm only crossing out
0.065 is still there?
Yes,
And
you're
your
only crossing out. So
0.0,
this is simplified now to x.
5, what are we, maybe like 5X to the 5th? No?
There's going to be 5 to the 5th, and then x to the 6th.
So 20, no?
It's not 25, that's 5 times 2. That's 5. That's 5 times 5. What's 5 to the 5th?
Big number.
Right, I'm not writing that big number. I'm leaving it like that. And then this is 1.00 times 10 to the negative 13th times denominator stuff, right? So 0.065. It's supposed to be 7.
And then you,
So
Would you
tell me
divide
what that
by-
is?
okay, that is,
Are you going in order? Yeah.
you multiply those two right there first before you multiply them by that, or is that even matter?
No, it doesn't matter. It's the P in PEMDAS. You're good.
We got
2.27.
times 10 to the negative 40.
Okay.
So then when you divide by the 5 to the 5,
Don't forget to put the 5 in parentheses.
2.01 times 16 to the negative 44.
So x to the 6th is equal to 2.00. So x is
Concentrate. Weight versus concentration. You know what I'm gonna do?
5. 0.24.
Yeah.
Times 10 to the negative 8. So then you divide that by with the 0.0020
Yes.
and multiply it by 100.
And then you add that. So you're deciding if X is even neglectable.
And it's like 0.2%.
Right, so 0.2% is way less than 5%, so we're neglectable, so check. So then this
Then you
is
plug
the,
that in up there and subtract it from like the 7x.
yep, so
Okay.
you have the new equilibrium, right? So that just makes our math easier, right? Now, all the rest of these on here, these are the 4, we did 4, actually we did 3 yesterday. We did this one, and it's done the same way, okay? And then we did 3, and I think it's not the same way. And I've saved those documents as a written form, and I'll put them online. I haven't put them online yet, though. So you can see how they're solved. But I think if you get neglecting X, that's how all the rest of these are solved. The complex ones are complex for a reason, because they are complex. Because the complex ones have like 5 steps versus just like 1 response. Okay, so I'm going to show you that one now. Alright, and then if you want to take a picture, you might already have this in place.
For the Allison's.
Alright, yeah, so for the complex ones, you always start off with writing your BC. You have your initial concentrations probably given to you. And then you try an icebox, and then try to neglect X, right? So you're going to try to do that. And if X is not neglectable, it's more than 5%, it's not neglectable. So you can try to, at that point, go, oh, can't neglect X, let's just put it in the solver, right? But sometimes the situation is not going to allow you to even play in the solver because you're going to get wrong numbers, just straight up. That situation is when K value is small.
I was like,
So it'd be a really, really, really small K value, but your initial concentrations show no reactants in all products. Small K value should be opposite of that, right? So if they give you initial concentrations like this, that means they want you to do something before you do equilibrium. They want you to let these products react and form reactants, and then the reactants are going to get equilibrium. Okay, so that's what I mean on this next step. So if you notice that you can't neglect X, before you try to do the solver, go, let's look at the scenario. And the scenario is this. Figure out who your LR is from your products. Do a BCE, a BDA box to go to completion. That means all of one of those products goes away, because that's the LR. Then you figure out, okay, you're probably going to proceed to the products at that point, and then you do an icebox.
so like 3 through 7 or if is that situation. So most of the time you only do 1 and 2.
Most times, yeah.
Okay, because I was scared when I saw 7 and 6.
That's not good. Alright, so I'm going to do this one. This will be loud. Okay.
For real.
Alright, so I'm going to do this one, and I didn't do this one in class this week.
Yeah, me too.
You good? Yes, Jordan, your stuff's in the back. Grab a calculator, grab paper, grab that extra little sheet. Yes.
Yeah, we're just doing 15 right now.
Set this up.
For letter A, it's asking for moles, and then on my paper you said something about molarity, so do I need to divide this by the 5 liter glass?
It's LN.
No, so to give you molarity, or give you molarity of X, that's not moles of X. So how do you get moles from volume of molarity?
You have to use the conversion as a conversion factor.
K2 minus LNK1 is equal to 1 over T2 minus
Wait, are you doing EA thingy?
I'm doing 15 minus T1.
Yeah. Oh, there's EA.
I think it was on that.
This column?
Do you have the right formula? It's like we can do that without we should have.
I don't know where I saw it.
Did you change this to K?
So I'm gonna take the grams and go to molarity with the liters given, okay?
So you like multiply by the molar mass.
Yeah, there's a
Divided by
separate
5.
formula.
Yep. So that's gonna give me moles, right? And then we divide by 5 liters.
1, but then 1.
5.00 liters, excuse me. And then this one's gonna be 294 grams divided by.
No, just like here's a random formula. Yeah.
I think I have it
Wait,
here.
that
Somewhere.
1A on the temper.
253.2
Did you just do?
grams, that will give me moles. Divided by 5 liters. I got you here.
I got 1.56 for that one.
I got 1.55 when I did it, because I had actually put 2.016.
That's
I
what
got, you did too?
yeah, but it was 1.55%.
Exactly what I said.
Maybe
I just have the math, so I'm just gonna go with what's here. You're both. Point 232 molar, okay? And then 0 for that, right?
yeah.
Oh, and then this one's actually an opposite scenario. Look here, your K value,
Products and all react.
right, and we have a huge K value. What does that tell us?
Oh, I wrote this down. Hold on. Right here. It's right here. Right here. The reaction to completion.
Oh, yeah, so the reaction goes to completion, right?
But that's not the analysis on this one.
Right, so this fraction's probably gonna go to completion. So let's let it go to completion first.
So
Because I
if
can
you
tell
do the
you,
mediate,
right, because you
So
know,
just use the moles.
What are the units?
but well, you can use the moles, but,
You can still use molarity.
you can use molarity only because it's almost like, a double standard. You can use molarity or moles in BDA boxes. You only can use molarity maximum size. So let this baby go to completion. Use the LR.
I do. So it wouldn't go in a 1/2 ratio for the HI. Wouldn't have produced that in a 1/2 ratio since. Or no, it's 2 to 1.
Yeah,
Would be
because it's producing twice as fast, right? 1.328 and
0.464.
okay, so now we've got this situation where we've got every equilibrium reaction. We've got some reactant and some product and 0
Put
product.
that to your ice box. That would be your I.
Yes, yes. Look at you. So now how many X's?
You subtract X from that, right?
Actually, both these are reactants, right? So you're going to almost subtract X from nothing.
So you're gonna add.
Right, you have to add it. So it's
You're
going
gonna
to be,
subtract it from the 2 HI.
right, so minus 2X because there's a 2 coefficient, right?
So plus X.
Right.
So then you have 1.32 plus X.
Okay.
2X.
Yeah, 2X. So in this one, think about it. The products are entirely favored, right? Do you think very many products are going to revert back? Probably not. Because that X is probably going to be really small compared.
Can you neglect both of those X's?
You're going to
And
be
then you have like a 7 10 equals X. No,
products are reactants.
0.464 to the square.
To the square.
Over 1.328.
Oh, sorry.
Forgot the 1.
1.328
Times X.
solve for X.
So you multiply that. So you do 7, 10 times the 0.328 times X.
1 here, so that's a 1 here. So when you rearrange it, you pretty much do cross multiplication division, right?
Yeah.
So you're multiplying these things by this, so you get
We get 7, like 7 times 1.328.
and then divided by,
Would you just multiply 1 by 1.32x?
Well, I tried to do it, but I don't.
Would that turn into like a whole number plus a number times x, or would it just be a number times x?
there should be a number times X.
Oh,
But really what you could do is, I know that X is going to be pulled over here, right? And I know sometimes we pull down
so
here.
you can divide what you get over there by the
I was just gonna say, since I know I'm gonna be multiplying by x here, and then dividing by 7/10 to get x, by itself, I just do this. I just go, okay, well, I know I gotta switch these numbers, so x is equal to 0.464 squared over this number still, and 7/10.
I corrected it. Yeah.
I got 2.2 is the negative.
No.
2.2.
Oh, here's what you do. Okay, what you do is you go.
Is that negligible?
You subtract it from the
Yeah, probably.
Do that for me real fast.
It's point, no, I think it's 4.92%.
Ooh, so really close,
Yeah.
but we're good. So that one actually was not too complex.
And so then you just plug it in up there and get the.
You get the equilibrium concentrations, yeah. Okay. Can you try some of these? Can you try the, the only 3S sign was number 2.
Where's this at?
It says complex problem set. And I'm coming back there.
So,
2, 3,
okay. 2, D, and E. That's like